Yeah. Good evening, good afternoon, all participants. Today is our webinar on fault loop impedance as well as the importance of fault loop impedance. We have this is probably about this year 2024. This is our second webinar. In fact, for the public, it may be the first webinar, but we already had some for some limited customers. Today, we are going to discuss about the CA regulations 2023. I'm sure most of you are aware of the CA regulation, so we don't explain what is there on the regulation, but we will explain the importance of the subject as well as the importance of fault loop impedance. Today, we have speaker Mr. Girish. One moment. Yeah. First of all, about NFE. For our members, as well as there are a few non-members as well, or members who have joined recently. A small introduction about NFE. We are a group of passionate engineering professionals working in the field of electrical safety. I'm sure all of you know our about NFE very well. We have our vision is to make electrically safe Bharat, protect people and property from electrical hazards such as fire due to short circuit and electrocution. We have set our vision, we have set our mission. Our mission is to strive to achieve the vision by getting accredited for products and personal certification, which shall focus on electrical safety by design, manufacturing, installation and maintenance of electrical products and installation by competent and qualified manpower, using quality sources, including products, process, and procedures. So the most important is electrical products and installation by competent and qualified manpower. We are trying to increase the competency or the skill of people, those who are involved in the electrical installation. My name is Gopakumar. I'm the president of NFE. I'm sure all of you know me very well. I'm a member in few of the BIS ETD committees, as well as a member in IEC, some of the technical committees, working groups of technical committees, TC64, TC81, and C37A, plus the LVDC committee. So these committees are basically creating global standards, the international, the IEC standards for electrotechnology, we say. We have the speaker, Mr. Girish, who is the manager, power quality and training division of. He's working with the Fluke Technologies, one of the global leader in power quality or testing and instruments, meters for testing the electrical installation. All of you know Fluke very well, or most of you know Fluke very well. It's a global company, one of the largest manufacturer of such protective device or testing device. Mr. Girish is his focus is in promoting and educating products related to industries, defense, educational institutions, and the renewable energy utility segment. And he is more concentrating on new technological instruments from Fluke, which are helping to the day-to-day maintenance activities of an electrical installation. Mr. Girish has got 14 years of experience. His work includes managing products like power quality, electrical products, and training manager in Fluke India. He is a general practitioner on energy saving and shares his inputs to end-to-end customer how to protect their assets by effective measurement, and he is a certified level 1 advanced thermographer. Mr. Girish has completed his education from KST College, Bangalore on electronics and communication. So now regarding the scheme which NFE is proposing or NFE is trying to create, all of you know very well that we are generating or we are creating the personal certification scheme. Which is where the skill and the competency of an engineer or a technician will be checked or will be verified based on the standard IS 732, which is equivalent to National Electrical Code of India, up to set parts, not the entire National Electrical Code. So we are trying to define two definitions which is given in the standard, which is skilled person as well as competent person. Around the globe, only skilled and competent person are allowed to do work where safety is involved. So our qualification will be based on IEC 60364 standard. As a result, the qualified engineer can work, get a chance to get employment anywhere in the world. So our scheme is based on, we call it as ESPCS, Electrical Safety Professional Certification Scheme. It is based on the ISO 17024 standard. The general requirement of bodies operating certified persons is the name of this particular standard. So NFE is only the scheme owner. So what we are trying to do is we are trying to create a skilled and competent person based on this particular standard. NFE is mentor of the scheme, and we are the holder of, or we are creating the licenses, or we are creating the rules for the scheme. In NFE, we have created a steering committee for handling the scheme. There is a core group, and there is the core group decides most of the technical subjects, and there is a secretariat supporting from Chennai. Regarding operationalization of the scheme, NFE owns and operates the scheme. The scheme evaluation and accreditation will be carried out by a personal and a national accreditation board. Under our scheme, personal certification bodies, they are those who are going to verify the skill and the knowledge of the person, and they are those who are going to certify the professionals based on the rules made by NFE. So NFE is not directly going to certify anybody. People used to ask, if I become an NFE member, can I become a certified professional? No. We are only making the rules. We are only going to define who is NFE certified engineer. The actual job will be done by personal certification body. The actual training will be carried out by training institutions. We are only monitoring and ensuring that all the candidates are meeting the requirements of our scheme. So our scheme, we have three kind of positions we are trying to make: NFE certified electrical consultant, NFE certified electrical installer, and NFE certified electrical safety verifier. As I said, these are based on the ISO 17024 standard. So basically, NFE certified electrical consultant is a person who is responsible for designing an electrical installation, predominantly low voltage and up to and including 33 kV supply. So basically, we are trying to concentrate electrical installation within the consumer premise. We are not going to talk anything about the distribution or the transmission generation. We are talking about the electrical installation belonging to a consumer or a prosumer. Similarly, NFE certified electrical installer, the person has to demonstrate his skills for carrying out an electrical installation. NFE certified safety verifier, he has to demonstrate his skills based on the standard and ensure that he is able to do his job. Now, the competence criteria, several criteria for competence, then I'm just skipping those part, are very much included in our website. I request all of you to go to the website and have a look. With this, I would like to stop the first session of the presentation. I would like to invite Mr. Girish for the presentation. We will have a discussion after the presentation of Mr. Girish. Over to you, Mr. Girish. You can share the screen.
Yeah, thank you, sir. Just confirm, sir, are you able to see my presentation?
Your sound is clear. Your sound is clear.
Yeah. So once again, good afternoon to all ladies and gentlemen. So myself, Girish, so I'm from Fluke, Bangalore. So today what we are going to discuss, so we are going to discuss more about what is fault loop impedance, from where it occurs, and why it is important on the safety perspective. So let us understand all this information, because today, if you look at the any industries or any manufacturing plants or anyway, the demand is actually increasing. So everywhere we can see a lot of new installations are coming up, and a lot of machines been getting installed. And when it comes to the knowledge about the safety aspects, there are a lot of professionals who have idea about it, and some of them they are looking at how to make this some of the tests, because when as a OEM, when we talk to many customers about fault loop impedance or about safety testings, uh, some of them have been certified, they know about it, but not everybody knows about why it is so much important in the field of electricity, right? So let us discuss more on that. So before that, a quick smart introduction about Fluke. So Fluke is a so, company which is founded by Mr. John Fluke Senior. So in 1948, the company was established. The most of you should have using Fluke products. So the Fluke main factory is in Everett. So it's in USA basically. So we have factories in Netherlands, UK, and Austria also. And when it comes to Fluke, so we our representation is worldwide. So every few years once we are coming out of new innovations, and these innovations is not that Fluke wants to develop. We work with the customers, we understand your pain point, and then we come out with the new innovations what we have just introduced. Loop impedance. So this is all the topic about. So loop impedance is definitely one of the important subject when it comes to the electrical safety, because earth fault loop impedance, also known as the earth loop impedance, is measured how easily can an electrical circuit can carry the fault current in the event of a fault to the earth. So basically it indicates the resistance of the circuit and its protective devices, such as fuses, or even you can call it as circuit breakers, which allows the flow of the fault current. When a lower earth fault loop impedance means that the circuit can carry fault current more easily, which helps to ensure the protected devices that operates quickly and effectively in the event of a fault. So thereby this also reduces the risk of electric shock or fire in the facilities. Now, when you look from the measurement perspective, so basically the impedance, whatever we are talking about, it is the resistance what we are measuring. So we are basically it uses the Ohm's law principle, and it uses the resistance for the calculation. So here V is equal to I into R. So there's a basic principle, everybody knows about it. So in the place of R, we are using the ZD for the measurement, and both the impedance or as well as the resistance. So the unit is ohms. Why it is important? Of course, so it's a very it's no everybody knows, should be knowing about by this time, that it is for the safety, for equipment safety, personal safety, everybody's safety who are working in that environment. It may be a commercial buildings, it may be a big offices, or it may be a residential buildings or industries, everywhere. Because this test is carried out to find out while a fault occurs in an electrical circuit, that electrical fault current will have strong enough to set off the circuit protection. If this fault is not and if the fault is left it as it is, then what happens to the equipment? The equipment definitely it's over a period of time, because the current, the amount of current sometimes it will be so high that it makes the equipment temperature to shoot up, and sometimes it's even it can even catch the fires. So in many buildings, so in many locations or facilities, if you see the earthing arrangements also, it will be different. So some they use a common earthing, some they try to develop different earthing arrangements. So what happens if there is a high resistance path in the circuit protection? So it may not operate at all. And over a period of time, what happens, because of this high fault current, it can lead the machine to fail, or the equipment to get the damages, or burnt out in the burnt out of the components, or sometimes it may also catch some fires. So regularly testing the loop impedance in your electrical system, so this will definitely allow to protect your assets. So that is very much important. It will allow to protect the assets as well as on the safety perspective. So nobody can come across any kind of shock or any kind of other issues, right? And you can also avoid unnecessary breakdowns in your facility. So otherwise, what will happen? It will definitely, because of the very high current, it can lead to unwanted damages on the electrical installations. So let us understand how from where the fault current occurs. Now, earth fault loop impedance is closely related to the protection of the electrical system, right? So the primary purpose of determining the earth fault loop impedance is to ensure that the protective devices in an electrical installation, that is, it may be a circuit breaker or a fuse boxes, or which are able to quickly detect and interrupt the flow of fault current. And whenever there is event occurs, the earth fault current occurs between the phase and the earthing. Okay. Now, assume that when a fault occurs in an electrical system, such as a short circuit or a ground fault, a large amount of current can flow through the fault path. The protected devices are designed to sense this fault current and quickly interrupt the power supply to the faulty circuit. Now, this prevents the further damage to the it also reduces the risk of electrical hazards or the electrical shocks. Now, in this condition, assume that there is a short circuit. Now, what happens? Because of this fault, the current is actually flowing in this way through the ground, and again it goes back to the main phase, and it can easily pass through the equipment. And from this high current, what happens to the equipment? Easily it will, over a period of time, it damages, or it may even create a fire. So there are fuses. Some of the fuses are designed in such a way that it can immediately the fuses breaks, and it will stop the that fault current to pass through. Right now, this is very much important because the earth fault loop impedance is to measure the total loop impedance of the fault path, including the resistance of the conductors, connections, and the protective devices. It also determines how easily the fault current can flow through the circuit. Now, lower impedance path also helps the circuit to lower total impedance and carry the fault current more easily, right? So to ensure the safety protection, the earth fault loop impedance should be kept within the acceptable limits specified by the electrical safety regulations. If there is a impedance, if the loop impedance is very high, what can happen? It can definitely cause the protective devices to operate slowly or not at all, and resulting the fault detection. And this definitely will put the system under risk, and over a period of time, definitely it can easily put into damages. So therefore, we have to measure, verify the earth fault loop impedance regularly. So this is an important part of the electrical system testing, and regularly doing the maintenances to ensure the proper protection and safety purpose. So these are the common connections, what actually in industries we can see. So there is a TNS systems, then we have DCS systems, and then we have TT systems. Now TNS systems, if you see here, from the load, it is directly connected to the main point of the grounding. So the grounding and the neutral will be connected to the main point. So this will be like a TNS system. And when it comes to the DC system, so near the consumer unit, the neutral will be grounded to the actual grounding. And when it comes to the TT system, so they will have a separate grounding systems. So there are different types of connections or topologies which is commonly used. So this is some more examples to showcase about TNC system, or TNC S system, TNS system, and TT systems, and IT systems. Now, who is responsible on checking the loop impedance testing? So everybody is responsible. Wherever there is electrical system, MCBs, RCBs are there, RCDs are there. Definitely, everybody, every engineer's responsibility to ensure that they say on the safety aspects. But when you look from the standard perspective, so standard is also providing guidelines how to do the test and why we need to do the test. What is the importance of that? Now, from the standards, the IEC 60364 so it's an international standard. So as per this standard, so there is a clear information provided, guidelines provided by them about the electrical installations in buildings, and why it is required to do the test, and what is the benefit of doing the test. And similarly, the NEC, National Electrical Code of India, so 2023, there was a lot of amendments, and guidelines are also provided by NEC about the importance of testing of the fault loop impedance test. And from our Indian standard, of course, IS 732 and IS 3034 and IS 3043. So there are multiple chapters below this. So definitely all these standards are recommending to regularly to check the electrical installations, right? It may be electric from the electrical panel and your equipment testings everywhere. You have to ensure that safety is one of the most important thing, because once we start regularly checking these fault loop impedance test and other tests recommended by the standards, so what happens? You are ensuring that your facility is under safety, and there is no if there is any kind of if there is any if you suspect any kind of issues in the electrical systems, you can quickly identify them and you can correct them. Okay. And again, the safety measurements on of electrical system based on CEA. So it also talks about the legal requirements of electrical safety systems, and it also talks about the personal requirements of a personal working on the electrical installation. So not everybody can go to the electrical installations and do the test. So there should be a certified person who should be knowing about those electrical installations and how to do the test, and choosing the right tool. Because there are a lot of tools available, but choosing the right tool for this measurement is very much important. And how to do the test, and while doing the test, what are the points needs to be noted, like wearing a PPE, and there are some other 10 points, close to 10 points are there. So all these points needs to be considered while taking the test in your facilities. Now, let us understand a little bit about the Electrical Code of India, so NEC. Now, if you go back a few months and few years back, there are a lot of incidents has occurred in many facilities, and most of the time, if you look at the any incident which has occurred, finally they come out with the answer saying that this incident has happened because of the short circuit. So that is the common word what they use. But from the other side, when we look at, there are thousands of people who are dying because of these kind of electrical accidents. And because of these electrical incidents, definitely most of the time there will be a fire breakout, and worth of millions of rupees. It may be a property, or it may be some what is say, some goods, or it may be something related to the process. Many assets have been got damaged. And so some of the data also reveals that 42% of fires in buildings are due to electrical short circuit. And they have also noted that approximately 5,000 deaths are due to electrical reasons itself. And majority of electrical accidents, such as fire, which does happen on the low voltage system. So remember it clearly that most of the facilities are working on low voltage side. Low voltage means less than 1,000 volt, isn't it? Because though you have a utility at your substation, so that will the voltage will be reduced, and from the category 4 environment, the voltage level will be less than 1,000 volt itself. So 415 at your electrical panel, and when you have a three-phase equipment, it may be close to less than 1,000 volt. And we have both three-phase and single-phase applications. And the other main reasons of the electrical accidents are because of the poor design, quality of the electrical installations, and not doing the maintenance job regularly. So that also is one of some of the reasons, and of course the old installations. And The code also provides some detailed protection measures for protecting the electrical shocks and some of the thermal effects, and protection against the overcurrent and short circuit current and voltage disturbances, and also what are the steps needs to be considered for right from the design, selection, erection and verification of an electrical system. See, any equipment when there is some disturbances in their particular path, so what happens, the machine's temperature also gradually shoots up. So this is also some kind of intimation for some electrical engineer or the engineer who is responsible can quickly identify these kind of problems and address them well in advance. Now, what are the major changes from the NEC point of view? So definitely NEC is talking about the electrical safety, no doubt about it. Under that, so as per Indian Standard Code of Practice of Electrical Wiring Installations, so they are talking about the design, erection and verification of low voltage side, which is rated up to 1000 volt. For AC side, and 1500 up to DC side. So this 1500 volt, we are talking about the solar installations. Now 1000 volt AC side, it is about within your facility. Okay. Now under this, what are the recommended tests? So loop impedance test, that is the fault current testing. So definitely that is one of the major. So when you're testing the loop impedance test, we have to ensure calculate the device is capturing the earth fault current as well as the prospective short circuit current. Then the cable continuity. So the cable continuity is not the normal continuity which we use in the multimeters, because there is a recommendation that the device has to inject some amount of current to measure the cable continuity. So in multimeter, what happens? The multimeter acts as a load when you're taking the measurement, but cable continuity, the tester has to inject some amount of current to measure the continuity. So I'll be showing that in the coming slide, how much current it is. Then also the phase sequence test. See, phase sequence, RYB, from your electrical panel till the load side, the sequence should be properly connected. Now, most of the electrical engineers and the technicians, everybody are have that idea, but still there may be a chances that a contractor might make a mistakes, right? So always we have to ensure that the phase sequence is also properly maintained. Otherwise, it will have a after effects on the load side. Regularly checking the insulation tests, depending upon the size of the equipment, and within facility low voltage side, definitely it's 1 kV is the one of the product, and then checking the RCD or ELCB or RCCBO. So these are the to check the tripping time and tripping current. So ultimately we are talking about the functionality of the RCDs which is installed for the safety purpose, right? So we are going to test about that. Regularly checking the earthing, that is the loop impedance, how much resistance is available, and the other test like earthbound test on the appliances or the medical equipment testings. Then regularly checking the power qualities and checking the efficiency of the equipments and safety to the electrical network. So definitely, if we care about the safety, we have to ensure that all these recommended tests by the standards are taken regular and done at a regular intervals of time. Why? This is because at the end of the day, your family is waiting for you. It may be you or your engineers. Their families are waiting for them. If there is we most of us know that a minimum of 30 milliampere current leakage current can lead to a cardiac arrest or maybe a death, right? So we have to ensure that personal safety as well as the equipment safety in the facilities are the most important. So let me quickly give a fair idea about the Fluke 1664 FC. So there is a multifunction tester. This multifunction tester definitely meets the NEC requirement. So under the NEC requirement, the first test is always the visual test. Why visual test? The visual test, before doing any test, we have to ensure that there is any in the electrical installation, whether there is any burning marks or burning signs on the electrical installations, or if there is any melted wires or loose or damaged connections or tripped breakers or blown fuses. And also you have to monitor the temperature, or do you hear any abnormal noises, or do you find any damaged cables, that is the insulations. And most of the time, doing the visual inspection itself, you can identify some of the problems before you actually carry out the test. And next is the loop impedance test. So this product has an automatic fight test. So I'll give you what is the automatic fight test it can do. Loop impedance test, and it will automatically calculate the prospective fault current and short circuit current. RCB testing, insulation test, continuity test with 250 milliampere current injection, phase sequence, and then earth loop test, then live voltage detection. Now, these auto sequences will definitely help you to do some of the test, because this will complete 5 tests in one go. That is the live voltage measurement. The moment when you connect to the one particular socket point, so to the electrical connection, it will directly detect the live voltage, and automatically it will do the loop impedance test with prospective short circuit current and the fault current. Then RCD tests, then insulation test. So RCD tripping time and tripping current, as well as the insulation test also, it will complete with voltage ranging from 50 to 1000 volt. Now, when you look from the NEC requirement, what is that we need to understand is not only from the fault impedance measurement. When you are doing the insulation test, the insulation test is recommended. We have to do it between line to earthing, line to neutral, as well as the neutral between earthing. Measuring the loop impedance test. So when we are doing the loop impedance test, ultimately when we have the low resistance, so it means that the fault current can easily pass through. When there is a high resistance, so automatically what happens, because of the high resistance, it resists the flow of current, isn't it? So it's a basic Ohm's law principle. Now let us understand or assume that there is a MCB of a 16 ampere, which is a circuit breaker, which is connected in the electrical installation. Now, what should be the resistance, that is the impedance value, and how much should be the prospective short circuit current? Now, if it is a 16 ampere MCB, so in general, between 5 to 10 times. So we will take as a 5 times current. So into 5 times current is the 96 ampere, and the nominal voltage between phase to neutral is 230 volts. So impedance is directly calculated here. So under this condition, the resistance should be close to 2.39 ohms. And the calculate and under this condition, when you use a meter and when you check it, so when you're getting a low resistance than 2.3 ohms, so it indicates that the path is very low, and it can easily allow close to 267 amperes. So it means that as per the circuit breaker, if it is 16 ampere circuit breaker, the expected current can go up to 96 ampere. But here, the short circuit current can be as much as 267 ampere, which is a little bit higher than the expected. Now, what are the maximum allowable ratings for different MCBs? Because there are type B, type C, and type D. So assume that if I take a 6 ampere MCBs, so it will be like the resistance, the fault loop impedance of that MCB is like 5.1, and 2. If it is type C, it is 2.56, and if it is type D, it is 1.2. So similarly, we have MCBs at different ratings. Like for example, in most of the cases, we could see 32 ampere MCB ratings. So if it is a type B, then it is 0.96, and if it is type C, it is 0.48, and if it is type D, it will be close to 0.24. So you can see the values here. So how much fault loop impedance the resistance will be available in these kind of conditions. So continuity test. So if you look from the electrical installation, the cables will be distributed in many places, right? From the panel, it is distributed everywhere. Now, the multimeter continuity is basically used for the smaller length of cables, and the multimeter, as I mentioned, it acts as a load. But from the NEC requirement and from the standard requirement, a continuity test is a test which has to inject 250 milliampere current. That is the recommendation. So what happens here? The device, when you connect it to the different systems in your electrical installation, if you want to measure the continuity, so once you connect it and once you measure the once you press the test button, so the multifunction tester has to inject a minimum of 250 milliampere current. Okay, and where it is actually this test all done in all conductive parts. It may be a foundation, earth ground system, or it is a protective earthing, metal water pipes or heating systems, or other wirings or lighting protections which are being connected in your facility. And the next recommended test is the RCD testing. See, RCD is always, it is, we have to know that this is also for the personal safety as well as the equipment safety. Now, over a period of time, what happens? See, when you look at the RCD, there will be a test button here. So once you press this button, what happens? Automatically this will trip. So once it trips, what happens? If it is live, it will cut off the power. Now, in this condition, whether this tripping is happening or not, when there is a real fault, when there is a fault current occurs in the system. So how do you verify that? Now, with the help of the multifunction tester, so what we are doing, assume that if it is a AC RCD type A, and maybe it's a 30 milliampere current. So when there is a 30 milliampere fault current, when it occurs, the RCD has to trip. Now, whether the functionality of the RCD is working fine or not, to verify that, once you connect a multifunction tester and choose the type of RCD, and once you select the current, 30 milliampere current, so what it does, it injects that 30 milliampere current, and it makes the RCD to trip. If the RCD is tripping, it is a clear indication that the RCDs are working completely fine. If it is not tripping, that is a real problem. Or if trips if it is taking time to trip, that is also a real problem, because most of the time, if a 30 milliampere RC installed, 30 milliampere is installed, so it has to trip at a 10 millisecond or 15 millisecond as recommended by the manufacturer. If it is not tripping at the speculated time, what happens? If it is tripping at 100 millisecond or 200 milliseconds, it's a faulty equipment. So this faulty RCD has been installed. So we have to replace that. And similarly, when it comes to the inside building, definitely the grounding wires will be everywhere. So though the master earth pit will be outside somewhere, outside the building, so internally you will be having the loop. So verifying the loop resistance of the earthing is also equally important, because if there is a break in the looping, what happens? If any equipment being installed inside the facility, what happens? The leakage current starts floating on the equipment, and if anybody touches it accidentally, then definitely there is a possible cause of shocks, or maybe serious injuries might happen. So to avoid that, even checking the loop also is equally important. The other safety test. So till now we were talking about the electrical installation in your facilities. The other electrical safety test is all about checking the appliances test, because if you have a facility, if you have your own canteens, definitely you will be having the class 1 and class 2 appliances, right? And even that class 2 class appliances also needs to be tested for the safety purpose, because we are talking about the earth bond resistance testing. Okay, so how much bonding is available between the earthing and the body. So some of the appliances will have the body as the earthing, right? So how much bond is available, and how much touch current tested. So how much protection is available on the touch current. Then insulation test, and also if there is a RCD is available in the facility, in that any special machine. So for example, assume that you have a special equipment been installed, and inside that equipment there are RCDs, so you can ensure that as per the standard. Even if somebody from the medical field, like from hospitals, definitely you have to ensure the even the medical equipments are well within the safety. See here, the many equipments will be operating on single phase, right? And they some of the equipments will be having the metal as the body. So if the grounding is not proper, so what can happen? The leakage current can easily pass through. Assume that there is a patient who is sitting, who is just lying on the bed, and maybe is in coma. Okay, so if by accidentally he touches the equipment, which is where the leakage current is floating on the that particular equipment, so what happens? He is feeling the shock, right, continuously. And there are a lot of incidents like this, which is and case studies are available in Google, where we can understand a lot of electrical shocks are happening even in the medical field. So here, checking all the electrical installations, MCBs, loop impedance of that, RCDs, and the earth looping. So all these points needs to be tested on a regular interval basis. So ultimately, this is for the safety of everyone, right? So this test needs to be regularly carried out to avoid unwanted electrical shocks, or even you can protect your assets being getting damaged because of the high fault current flowing through that. So with that, I've come to the end of the short presentation. So if you have any queries about this, we are free to answer
Thank
that.
you. Mr. Girish, we will have, in continuation to your presentation, I have few points, 2, 3 points, but
Yes.
very important points to share. If you can unshare your screen, probably then I can share mine.
Yeah, I've stopped sharing, sir.
Yeah, I'm sure my screen is visible now. And let me put it on to the full screen mode. I'm sure you are able to see the screen. You see, fire accidents from appliances are quite common in our country. Very, very common every time. The video which you are looking is an incident in which an air conditioner killed almost, you can see here from this place onwards, an air conditioner, a split air conditioner in a hospital ICU. You watch carefully, please. Put the video. I disconnected the video because the recording of the video, because if we share some critical videos, these are given to me as a personal relation. So the person who gave the video told not to share it. That is the reason for not recording this session. Now over to you, Mr. Girish. The first question is, what are practical cases of path or location of high impedance? You can also find the question in Q&A. If you open Q&A, you can see the question. What are practical cases of path or location of high impedance? The question is from Mr. Shailendra Rana. Actually, it's a very simple question. I can answer. It's the high impedance. Most of the time, if you look at earth fault loop impedance, the high impedance is due to non-existence of a fault return path. Instead of a metallic fault return path, we provide two, three earth electrodes, and basically all the connections are corroded, loose contacts. As a result, impedance is high. In line to line, of course, most of the time, our wire sizes are over. Most often, the wire sizes and circuit protective devices are oversized. Similarly, the joint resistances are also too much. Instead of making the joint resistance or the connections with a very small resistance, most often the connections externally it look good, but we don't have the habit of checking the resistance of each and every joint. Say for example, certain applications need a joint resistance of 10 milliohm, but practically it may be 100 milliohm, because we don't check. So basically it is the loose contacts and the non-existence of fault return path. Thank you very much, Mr. Shailendra. The next question is from Mr. Jagadish Chandra Bhatt. What is difference between Megger testing or this testing instrument? Megger testing is very common in electrical engineering last 30, 40 years, like me. Over to you, Mr. Girish.
Yeah, thank you, sir. So, sir, mega testing. So, generally, the mega testing in the industry, they call it as mega testing. So, that is the insulation testing. But this tester is actually a multifunction tester, where it will help you to test right from the loop impedance test, then RCD testing, that is the tripping time and tripping current, 1 kV insulation testing, and you can also check the phase sequence in the electrical connections and all other tests. So this is basically the test, which is it's a multifunction tester. So both are two different products actually.
Okay, so both are two different products. The Megger or it is the insulation tester. Basically, it is used to check the insulation resistance of the between the earth and the current carrying conductors, basically, or between the current carrying conductors if there is no load connected. So, and this one is the testing the impedance of the entire circuit. The next question from Mr. Keshavam, is fault loop impedance applicable for IT earthing system also? Mr. Girish, any
Yes, sir.
answer? Of course, it is not
Yeah, of course.
applicable in IT earthing because IT earthing system, the concept is totally different. But very important, the biomedical equipment or the equipment which is connected to the IT system, you must ensure that the available fault, there is enough fault current to disconnect in case of a line to neutral fault. So the test is necessary, but earth fault loop may not be necessary. The loop is necessary.
No, not necessary. Yeah.
Yeah. The next question, what about testing meters and class and type of enclosure from Mr. Amritilal?
I'm not sure about this, sir. What is asking at?
No, it's standard. I see 61557, I believe. I also don't look at the standard for a long time now. If you need, I can tell you the standard, but I'm not an expert in that particular standard because I never read the test instrument, the standard.
So is
It
it
is
about asking about the testing the meters, the measuring meters, class and measures?
the accuracy class of the meter.
Accuracy of the class of the meter. Okay. So,
And type enclosure, I am not sure what Mr. Amrit wanted
yeah.
to explain. Mr. Amrit, if you can type in detail, we will be happy.
Yes, sir. Yeah. Because
Probably
one
we will keep
important.
this answer pending. We go to the next question and then probably we come back to this question. Whether
Okay.
the loop impedance test is applicable for 250, 630 or 1250 amps breaker, and if it is yes, what limit of ZS?
I have from the standard I could not find for this high kind values for this high kind of breakers. So if you have any answer, sir, you can help me on this.
Yeah, you see, whatever written in the standard is the bare minimum. For example, if you look at the tables in the NEC or IEC 60364 or Part 6 or the IS 732, the tables and the verification is most suited for a small application, such as a residential application. But once when we go to industrial application, it is the skill of the engineer which decides what exactly has to do. So the competent person should decide whether these tests are required or not. Of course, these are required, and the fault loop impedance or the line-to-line impedance you can calculate based on the available voltage and the fault current required to disconnect the device and make a safety margin of 30%. You can very well calculate. These calculations are there in the standard. So Mr. Narendra is asking, please share case studies platform.
Yes, sir. So I think he is looking for the more of case studies
Yes,
information.
yes. Actually, we didn't prepare any case studies, but I have probably I made maybe thousands of fault loop impedance tests. I think it is better not to share the case study because all these customers will come and shoot me down. Because most of the cases, 90% of the cases, I can make a statement that the test fails. You have a 250 amps MCCB, and the MCCB require, let us say, X value of fault current and certain value of impedance, and most of the time the impedance is high. the available fault current is much lower than the current which is required to disconnect within a short time. So this is what I'm always trying to stress, that maximum fault current, expected fault current. Of course, you have to size the conductors and you have to size the protective device based on the fault maximum expected fault current. But it is equally or more important that the protective device is able to trip. So if you look at case study, I repeat, most of the cases or majority of the cases, the testing is out of 100 circuits in an industry, probably 60, 70 fails. And balance also, the 60, 70 also, or the 30, 40, 50% it may pass, but they are most of the time at the minimum level. Say, for example, a 250 amps MCCB need 2500 amps, probably the current is 2600 amps. So as a result, we can see that it is tripping, but it is not the maximum current, but it is, the minimum current is quite less. So the next question is, what if in case the circuit supplied by ELCB, not MCB, what about fault tube impedance testing in this case, Ms. Lakshmi Priya? Can you reply, Mr. Girish?
So ELCB also needs to be verified because that is also used for the safety purpose. Now, functionality of ELCB, like whether it is tripping, the tripping time and tripping current is equally important. And if there is no MCB, so the loop impedance test, so if now it doesn't make it doesn't gives any answers there, because see, MCB we are talking about, we are trying to calculate the how much short circuit current and the fault current that particular electrical system can withstand, right? So if there is no MCB, then it is difficult for us to calculate all this information.
Yeah.
So do you want to add anything, any more points here on this?
In case of ELCB, of course, the calculation is a little bit different, but you have to test you see, the test, what is written in the standard or the standard way of explanation is efficiency of automatic disconnection of supply. So first is you have to find out the type of protective device which is used for the disconnection, and that particular device should trip. If it's an ELCB, of course, the ELCB has to be tested. Sorry, not ELCB, RCD. The RCD has to be tested. RCD testing is also there in that particular meter, which Mr. Girish was explaining. So somebody is asking the fire accident video. Sorry, Mr. Narendra, we cannot share the fire accident video. This is handed over because of personal relation. That is why I put the video off. Can insulation monitoring device help in identifying the fault tube impedance? Of course, no. Insulation monitoring device is
insulation
completely
insulation test is a completely different measurement, and loop impedance is a completely different measurement. So insulation test, what we are doing on the conductors under when it is not in a live condition, so we have to do the insulation test. So what we are doing, we are applying a high voltage and very low current to check the insulating material of that particular conductor. So both are two different devices, actually, two different tests. Sorry.
But here the question is insulation monitoring device. It is not the insulation test. Insulation monitoring device help in finding out fault tube impedance. No, insulation monitoring device will monitor only the insulation of the installation. It cannot identify fault tube impedance. There is a question: how do you measure fault tube impedance of a three-phase load?
Yeah. So I should have kept one slide there. Yes, there is a possibility that we can measure between phase to phase the loop impedance measurement. The facility is available in the insulation tester. So it's only the connections what we toggle between.
Yeah. Thank you. So is it possible to measure loop impedance of PE/NE loops from Mr. Ashok Suman?
So as per standard, I understand between phase and the earthing is what the loop impedance is being tested, and that is a standard practice. So
that is called as earth fault loop impedance between line to earth.
Earth.
It doesn't
Yeah.
mean that line to neutral and can be tested. Of course, line to neutral also can be tested with the same meter. Line to line also can be tested, but neutral to earth is not possible because there is no voltage between N and E. So this device to test it need the applied the supply voltage is required for making the test. So we have the next question from Mr. Kamlesh Kumar. Three-phase system loop are made of RY, YB, CR, RE, RM. In this, which measured value should consider to verify the result? Probably
Uh,
all the things, depending upon the situation.
Correct. So first thing is like what is if almost if the resistance is low for that particular electrical installation, then I think you have to consider all the three. If any one of the phase is having high resistance, then that is the place where the correction needs to be taken care.
Yes, actually, what happened is, there is a challenge I am facing in the industry. We were taking classes for quite long now and talking about fault loop impedance, or let's say propagating fault loop impedance, maybe last 3, 4, 5 years. What happened is there are, sometimes people ask, can I get a participation certificate of the webinar? Initially, we were also graciously giving the participation certificate. So with this, half knowledge, there are some industries who called me and told that, you gave a certificate and one gentleman came with a small meter and tested our entire installation, but after a few days, again, the accident happened. So then, this was actually putting us in trouble. Please note that it is not the fault loop impedance alone. It is a sequence of tests. The IS 732 or NEC has provided a sequence of tests, starting with before the test you should do visual inspection, then you should do the sequence of the test. It doesn't mean that out of 10 tests, if you take only the fault loop impedance and test the fault loop impedance and believe that the rest of the installation is in a safe condition, is wrong. You should do the entire. If you are doing only fault loop impedance, the conclusion is probably the efficiency of automatic disconnection is good. That's all. It doesn't mean that the installation is safe. So now we have coming back to the question of Mr. Amritlal. When you are trying to test an installation, what will be the test voltage of the instrument or the safety of the person likely to get shock from the test equipment?
Yeah, it's a really
What do
good
you
question.
think?
Yeah, it's a very really good question, and we need to understand. See, any test equipment, first of all, when you're doing any test, whether in an online condition or offline condition, the recommendation is not the any person while doing the test, the other person should not touch the device which is under test. That is the first thing. Second thing, since the testers, it may be a multifunction tester like a loop impedance measurement or a insulation measurement or RCD measurement. So it is injecting a very low current. So it doesn't mean that you are safe, but still always ensure that once the connections are made, you be little bit away, maintain some distance while making the test. So that is a recommended practices, and also try to use some PPE kits so that you'll be protected from the unwanted shocks. But the test equipment will not create any shock to the person who is holding the equipment, because all these devices will be tested as per the IC guidelines.
Yes. So basically, this device is not creating any voltage. It is only using the voltage available on the supply to make the test. So this cannot. But anyway, the minimum basic required safety measures are already there on the guideline of the device. Now we have a question from Mr. Subodh Bide. I would recommend that Mr. Subodh, your question is not very clear. What about arc resistance between line to earth and line to line with respect to measured loop impedance? Probably after two more questions, we will come back to you. The next question is from Mr. Ullas Vajre. Can loop impedance be measured in live circuits without shutting down the equipment in three-phase circuits like a motor?
Yes, actually,
Of
loop
course,
impedance test, we have to do it on a live condition only. So there are some recommended
it's a
tests.
live.
Yeah. So a loop impedance test, RCD test, you have to do in a live condition. Yes, sir. You can add, sir.
I used to do this test in industry. How do we do it, or how do I educate my people, my technicians to do it is in larger installation with higher circuit currents. There we first make the arc flash analysis. We have to find out. We have to select the appropriate arc suit. Since this is a live test, you have to open sometimes the bus bars or you open some of the live parts. So the person has to wear the appropriate PPEs and appropriate, for example, the arc flash suit, and then only you can do the test. Don't try to open in a live condition and do the test. This is for high current application, high current measurement. Now high current measurement, the problem is this multifunction meter will not work. Multifunction meter, the test current is quite less. So with the less current, the accuracy at a higher or a very high current application may not work out. You have to have a meter with a high test current. Let's say I think there are test devices available up to 1000 amperes of test current, which are highly accurate. But I think the 1000 ampere fault loop impedance tester is probably maybe about 15 to 20 lakh rupees. It's quite expensive. Of course, Mr. Ullas Vajra, it is a live condition, live test. So then Mr. Amit Vyas, multimeter also measures resistance. Then what is the difference between multimeter and the earth loop impedance meter?
Yeah, it's a good question, sir, because this is the common confusion many customers have. That see, multimeter, when you make any measurement, so actually multimeter acts as a load. Okay, it is taking the signal to measure, and it is not sourcing anything. When in the case of loop impedance test or insulation test or RCD testing, we are in the device, the tester has to inject some amount of current and voltage. So because it is calculating the resistance, isn't it? So to calculate the resistance, the current and voltage is injected from the device. So that's the reason multifunction testers will inject the required amount of current and the voltage recommended by the standard, and it will calculate the resistance.
Yes, both are different subject. Multimeter can check only whether the two parts are connected, whereas loop means the entire loop, starting from the fault back to the source, through the source, returning back to the faulty live conductor. It is the impedance, or it is the entire loop is what is tested. Now we have a question from Mr. Subodh Bide. If there is a fault between line and neutral in the form of an arc instead of a solid contact, in that case, arc resistance will be added, or what will be additional part of the loop impedance? Mr. Subodh, what we are testing, or what the standard recommendation is, a fault of negligible impedance. Fault of negligible impedance means, for this purpose of testing, the impedance of the fault is considered as 0, because the condition is a live conductor is directly in touch with a metallic exposed extraneous conductive part. That means exposed extraneous conductive parts are at the potential of the live conductor. Then the disconnection time comes into picture, and we ensure that the disconnection is happening within that particular time. If there is an impedance of the arc, or if there is an impedance in the fault, the potential of the exposed extraneous conductive parts are anything between 0 to 230 volt. It is not exactly 230, maybe 110, or maybe a different potential. Under that condition, the disconnection time will be more. You don't need to disconnect within the time prescribed in the standard. The time prescribed is for a 230 volt fault. So basically, the test is confirmed for a fault of negligible impedance. You can find it in the standard. So this is with this, I think we have almost closed the questions and answer questions Q&A. I don't know whether any questions are there on the chat box. Now, if any of the members wanted to ask a question, probably you can raise your hand. We have Mr. Apau sir
Yes,
in our office. Apau sir, if you wanted to add any point, please.
Yes. Thank you, all the participants. It's a very good presentation by
I
Girish.
request you to switch on the camera if the background is good.
Yeah, I'm in our office, in our headquarters office. I came for some other purpose, so I am presenting here. So the thing is, I would like to supplement Mr. Girish on only one point. One person has raised a question whether we can use a multimeter or a loop impedance meter. So the measurement is something like it's a separate protocol. See, we have, as Gopa said, we have C0557 for measurement to specify the accuracy of the equipment that we are going to use. See, the accuracy is in turn depend on the confidence level. Your measured result, for example, 95% of the confidence level means 95% of the test results shall be within an error of 10%. That is the specification. These are the detailed measurement protocol. You can check the manufacturer's manufacturer brochure for particular range, say 1 ohm range or 10 ohm range or 1 milliohm range. They will specify as per IEC what is our guaranteed deviation from the what do you call that real value. We can't always say real value. There will be deviation from the real value that is measured as a confidence level. If you can achieve a multimeter with that confidence level, there's no question of raising a dispute, because every meter has its own limitations. You can't expect a multimeter to operate at say 10% with a confidence level at 1 ohm. If you compare it with the loop impedance method, then you can know the difference. In simple term, what I can say is you can use a 1000-volt tongue tester to measure a 1 volt neutral to earth voltage. We can't say whether it is 1 volt or 10 volt. The deviation, the measurement protocol itself is clear. The manufacturer provides the brochure. You check the brochure whether the assured result, because we are dealing with the safety and earth fault loop impedance plays a vital role. So we can't compromise the safety. We have to go as per IEC C0557 and use a calibrated meter. Insist from the manufacturer, insist from grid, whether you have a calibration certificate for the declaration you are offering for your meter. So these are things the consumer should be aware whether we are using a right type of meter. That's the main thing. We have to use a right type of meter and an optimum accuracy. For example, we can't have a multifunction meter, say 5.5 digit or 7.5 digit, as Gopa said, at a cost of 30 lakhs to measure the F-fault impedance to an accuracy of 1% of 1 milliohm. These are all not required. We can optimum meter at an affordable cost and ensure safety. These are the basic things required for measurement. So that's what I can say. And another thing, one more person has asked about the 1250 ohms bracket. What is this? Completely a design aspect. See, the thing is, as Gopa said, we should not design absolute impedance for the probable fault level, say 30 kA or 50 kA. The kA that will be seen by the circuit will be in the order of 4 to 5 kA after allowing the various sensing devices. Say you have a CT, you have a setting for the time multiplier setting, you have a setting for the everything is there. Though finally, what is the standard say is the permissible touch voltage and the permissible duration. That is achieved in a simple word. In LT, you don't analyze all these aspects. You just see whether the 230 by the tripping current of the protective device. That is the F for loop impedance. So there's no confusion. For 1050, it automatically comes to, I have just calculated, just 60 milliohms for the phase conductor up to a length of 750 meters. Because we are using a very big size of conductor for that transformer. So the length doesn't cause your fault looping. It doesn't increase. It will be in the order of milliohms only. Again, the protective earthing conductor will also be very minimum because of its size. For example, if you use a say 60 by 8, 480 square mm, that copper conductor will yield a resistance of just 2 milliohm. So it gets automatically solved. So if you go into the design aspect, it gets automatically solved. You use the right type of instrument. You assess the duration of fault of the tripping device and the current required to trip the device. That's the thing behind the fault loop. That's what I can add, Mr. Papa. Thank you.
Yeah, thank you, sir. Thank you, sir. We have two people who have raised the hand. Mr. Davis, Mr. Davis, you can unmute yourself and you can have the question, please.
Yeah. Am I audible now?
Yes.
Yes, sir.
Yeah, thank you. Thank you, Babumar sir, after a long time. Yeah, my question is to Mr. Girish for your excellent presentation. Now, you have mentioned that continuity test. Now, this continuity test, is it performed online? Because my question is that you are also saying that during continuity test, you are injecting some milliampere into the system and then checking the continuity. So, if it is online or is it offline?
Sir, continuity test is done on offline conditions.
Okay, it is done in an offline condition.
Yeah.
And all the fault loop what you talked about, it is done online.
Online condition. So like loop impedance test, then RCD functionality test. Then even if you want to check the earth looping, that also tested on the live condition itself.
But when you do the RCD, when you do on online, if RCD trips, that means the entire system will trip.
Correct. So we are deliberately.
Then it is offline. Okay, understand.
Then it becomes offline. See, we are deliberately making the RCD to trip to ensure whether it is working fine or not.
Okay, but
So actually, out of the 10 tests listed in the standard, the first 6 tests are in off condition. First 4 is in off condition. The next 6 is in on condition.
Okay.
So that is how it is. If you look at the standard, these are actually written in the standard.
Okay. Thank you, sir. Thank you.
Yeah, thank you. Sir. We have Mr. Ullas Vajirai. Mr. Ullas, you can unmute yourself and speak.
Yes, sir. Yeah, my question is same as Mr. Davis has asked. When you talk about loop impedances, I asked this question to many this impedance meter manufacturer. Some of them said no, we can conduct it online for three-phase circuits. Now Mr. Girish is telling it can be done online. So my question is, if the motor is running at 415 volt and say drawing some 30 ampere current, so what voltage and current you are injecting in the circuit and how you are measuring the loop impedance in that case?
Sir, actually, this device is not injecting any additional voltage into the system. The device is first of all, it is there in IS 732. If you look at clause 1 of the annexure, it is very clearly explained. It measures the operating voltage. Let's say line to neutral or line to earth, 230 volt. First is 230 volt is measured. Next, for 2 cycles, it makes a short circuit of the line and earth or line and neutral through a fixed resistor. Let's say a 10 ohm resistor. The line and earth is shorted for 2 cycles. When this is shorted, there is a voltage drop because the current is more. There is a voltage drop. Let us say 230 will drop to 229.5 or 229.75, 0.25 volt to drop because of this additional resistance and because of the additional current through the circuit. So this resistor, the voltage drop and the excess current is measured and the rest is calculated by the meter. As a result, the impedance of the circuit is done. The meter as such doesn't inject any potential into the circuit. And since the test is only for 40 or 1 cycle, or it is not even 40 milliseconds, I think it is for 1 cycle, the circuit also doesn't sense this current. I hope I am clear. I am correct, Mr. Girish. If I am wrong, you can correct.
No, it's correct.
Thank you. So also we have one more person who has raised the hand, Mr. Shovan Babu. Mr. Shovan Babu, if you have any question, you can ask, or yeah, please.
Yeah, I think he has put a question how to calibrate loop impedance tester. We have a unit of other make. Is calibration necessary like any other measuring device? Sir, as per ISO guidelines, yes, any measuring devices needs to be calibrated yearly once. See, it may be from any company, but it has to be calibrated from the proper calibration lab to ensure that the that particular measuring device is working fine on.
Okay, so
But
my question,
unfortunately, there is no lab in India who can calibrate.
yeah, that is my question. That is my question exactly. Because other meters like multimeters or any other meter, they have a standard decade resistance box through which they measure the resistance or such. But this particular meter, we measure on live circuit. So it depends upon the client's premises voltage. So we are not sure of the exact voltage, right? So is there any procedure to calibrate our devices like this?
Yes, sir. What I will do, sir, I'll share the details through Gopakumar sir about
Okay.
this calibration. I'll share.
Okay,
So
thank
at
you,
the moment,
sir.
there is no facility available in India. It's a question of time. These requirements came only recently. Over a period of time, there will be several companies. So what we do in what I recommend or what I do is we have got, I think, multiple number of testers, several meters of different current rating. Always, once in 2 months we are buying a new meter. So we always have a meter which is, because the manufacturer give calibration for 1 year. Then we used to check the accuracy between 2 meters just to ensure that the old meters are in good condition. This is the only possible way according to me. So I think there is no further question, and there is one more. Okay, there is no question, and I think we are in time. 5:30, 1 hour 30 minutes is our webinar time. We would like to thank all the participants, all the attendees for attending our webinar. We request you to carry on the message of NFE to make the nation electrically safe. Also, please note that a lot of new technologies are coming into picture. This fault loop impedance is, the limit is not the one which is written in the standard or in the regulation. There are so many purposes, applications you can use it. With this, we would like to close the webinar. Thank you very much once again. And we can close it. Thank you. Lakshmi, you can close the webinar. Probably Mr. Giri